For a rational zeros theorems, you want to list all the possible rational zeros, and the rational zeros has the form P over Q, and P is a factor of A naught. A naught is this one right here, okay, and then we have Q is a factor of AN, and that's AN. Okay, so we're gonna list all the possible P over Q, all the possible rational zeros. So don't forget, when we list all the zeros, you want to include the positive and the negative. All right, so we have P. In this case is 2, and Q is -3. Okay, so the factors of 2's is plus and minus 1 and plus and minus 2. Factor of 3, -3 is plus and minus 1 and plus and minus 3. So I'm gonna put all of them together. So we have, how about we have 1 over 1? So we go with 1, plus and minus 1. And then we have plus and minus 1 over 3. So I pretty much just take the factor here, and I go this one over this one, this one over this one. Now I'm gonna go this plus and minus 2 over plus and minus 1, and then plus and minus 2 over plus and minus 3. So that's how I do it. So I have plus and minus 2 here, plus and minus 2 over 3. And that's how I list all the possible rational zeros. Now the Descartes rule of sign. So we pretty much want to look for the change in sign. So you want to see when they change from positive to negative or vice versa. So you see right here for f of x, we have a positive and a negative. So we have this one change right here. So that's 1. Negative, negative, nothing. So negative to a positive, that's 2. So possible real zeros would be 2. And then don't forget, you're going to have to take away 2. So 2 minus 2 is 0. Now, for the negative, you plug negative in. Now, if you plug negative in and it's an even exponent, nothing changed. So we still have that. If it's odd, it's going to change. So I have, instead of a positive, I have negative. For the x squared, it's just going to be the same. For x, it's going to change. And for the constant, of course, it's going to stay the same. Now, we have from a positive to a negative. So this is a positive to a negative, so that's one change. And then we have a negative to a positive. That's another change. So we have 2. And then same thing, I have to take away 2. So there's 0. There's a possibility that we have 0 positive and 0 negative real zeros. All right, moving on to number 18. Number 18, we know that it has at least one rational. So you can use the rational zero theorem to guess that number. Now you see right here, we have negative 15 for A naught and 2 for AN. So 15 is a big number because the factors for 15 we have plus and minus 1, plus and minus 3, plus and minus 5, and plus and minus 15. Okay, usually I pick 1, but 1 is way too easy. So how about we go for 3? So how about I'm gonna pick 3 as a rational zeros, and then from there you can pick 5 if you want. See if we have at least one 0. So how do we know? We can do synthetic division. So I'm gonna pick negative 3 and do synthetic. 2, negative 3, negative 32, negative 15. 2, negative 6, negative 9, 27, negative 5, 15. Oh, good. We have the remainder equal to 0. So we know negative 3 is as a 0. So now I can have 2x squared minus 9x minus 5 equals 0. I wonder if we can factor this. I'm going to try to factor first. If we can't, we go back and do quadratic equation, quadratic formula. Okay, so negative 10, because I take 2 times negative 5. So pick two numbers. When you multiply, you get negative 10. When you add, you get negative 9. So in this case, is negative 10 and 1. All right, so I'm going to divide by 2, reduce it. So we have it. We're lucky. We get to factor. So I have 2x plus 1. Okay, so x equals to 5 here. For 2x plus 1, that's going to be negative 1/2. And don't forget, originally we have x equals negative 3. So those are the zeros of this function. For number 20, I understand that this problem can get really messy, so make sure you do it carefully, but hopefully you can recognize that 3 minus 6i and 3 plus 6i's are conjugate, complex conjugate. So let's just FOIL. So we have x squared, and then we're gonna multiply 1 by 1, right? So I have negative 3 plus 6i times x. And then I have negative 3 minus 6i times x. And then I have positive 3 minus 6i times 3 plus 6i. Okay, now let's try to simplify that. So you can see that right here we have negative 3x minus 6ix minus 3x plus 6ix. Now the last one is the conjugate. So we have 3 squared minus 6i squared. Now I just want to remind you a plus b times a minus b is a squared minus b squared. So that's what I did for the conjugate. Now let's just clean it up. So what I have right here, this one and this one cancel out. We have x squared minus 6x. Now, this one is I squared, don't forget I squared is negative 1. With the negative in front, so it's turned into a positive. So what I have right here, in fact, is positive 36. So plus 36. So I simplify one more time. I ended up with x squared minus 6x plus 45. And that's our final answer. For number 21, we have the following zeros. So you can just plug it in factor form. However, don't forget that for the complex zeros, you're going to have to include the conjugate as well. So we have x minus negative 3 plus I, but we also have the negative 3 minus I. That's the conjugate. And then from here, you multiply it out to get our polynomial. Now, for number 22, they give you 1 as a 0, so we can just go ahead and use that one, and then I can just proceed the synthetic division. I love synthetic division because it's easy. So we have 1, 1, 8, negative 10. Drop down 1, 2, 2, 10, 10, 0. Bingo. Since I have 0, I know for sure that this one right here is a 0. So I have x squared plus 2x plus 10 equal to 0. Okay, as you can see, we cannot factor here. So I'm just going to complete the square. If you want to use quadratic formula, you are welcome to do that. X squared plus 2x equals to negative 10. I'm going to add to complete the square, so add 1. 2 divided by 2, square is 1. So add 1. So what I have is x plus 1 square. This one is negative 9. Taking the square root, I ended up with plus and minus 3i. Okay, so I have to move the negative 1 over. So there are my two zeros. Okay, so let's just list them out. We have g of x, the original 0, which is 1. And then the two zeros I found, x minus negative 1 plus 3i, and x minus negative 1 minus 3i. So for these problems, we know that we have at least one rational 0, and I'm just going to pick one because this is a long polynomial, so I'm going to pick one, see if one is a rational 0 or not. So I'm going to do synthetic. So we have 7 here, 7, negative 33, negative 9, negative 5. Oh, good. So we do have a 0. Okay, so 1 is a 0. The problem is we ended up with x cubed here. So we're going to have to try synthetic one more time. You see right here, I have a 5. So most likely, 1 of the 0 is going to be 5. So I'm just going to try 5. And then I'm going to put our new polynomial here and proceed synthetic. Good, so this one is a 0 as well. Okay, now we ended up with a quadratic, so I can just proceed with the quadratic formula. This one I'm going to use quadratic formula because of the 7 here. So negative 2 plus and minus x equals negative 2 plus and minus square root of 2 squared, which is 4, minus 4 times 7 times 1, everything over 2 times 7. And then, of course, we have to reduce it. Okay, I have to simplify inside the radical right there. So what you can see is negative 2 plus and minus square root of negative 4 times 6. So we can take the negative 4 out, which is 2i. Don't forget to take the negative out because you don't want to leave negative under the radical. Now I can reduce it. I can reduce. So I ended up with 1 plus and minus I square root of 6 over 7. So those are my complex zeros, and the first two are my real zero.